Okay, so everything is reassembled again to do the testing on this. Got all the connectors connected up here in the right order. You can't see it, but the BMS connector is down there. Got our main connector over here from the battery management system to the DC to AC converter and then the DC to DC converter. But the one thing I wanted to show is what happens if the main controller over there doesn't communicate to the BMS, the board that we were just looking at that's beneath the main board here. And this jumper goes to this board, but it's really communicating between the main controller on this board and the BMS to communicate like, hey, everything is functioning properly. So with it disconnected, I2C communication now is disconnected between the front controller, the front of the unit, and the main board and the BMS. If I try to do anything, like if I try to plug it in, it'll turn on and like go into its reset state, but won't do anything further. It's just gonna turn all the lights off. Nothing will work. It won't let you turn anything on, nor will it actually allow the system to operate, which is slick. I mean, it's what it's supposed to do. So I'm gonna just keep everything as it is, plug this connector in, and everything should continue to operate, or should resume. Now with that plugged in, repeat the same thing over again. There we go. You can see it's showing 9% right there. If I plug this in, and we get 79 watts. It's coming in 119 watts. That's basically what should be at when it's charging on this brick that it came with. So pretty good. So okay, I'm gonna get ready to set up for the test here. Actually, let's leave it plugged in while I'm doing this. Now I wanna charge it up just a little bit, let it go to about maybe 20%, and then I'm gonna throw 2 heater loads on the AC output. We'll see if we see any heating anywhere that there shouldn't be heating. If that all goes to plan, I'm happy with it. I'll just reassemble it and keep on using it. But we're gonna give it a little bit of time to charge here. It's at 119 watts. I might throw the additional charger on there. I can throw a 70 watt charger to run in tandem with this, so it charges at about 200 watts. So it'll charge a little quicker, but I want to just kind of let it slow charge for a while and see how that goes. Okay, I'm gonna let it go for a little bit and then we'll come back and test some stuff out. And now we say turn on our AC output over here. See that it's showing 24 watts, then it settles down to about 5 watts. That's the quiescent draw. I wish the newer Anker power stations would do that and show what this is actually drawing, just sitting doing nothing, because every single one of the inverters have a quiescent draw. So anyways, 5 watts. And now I'm just gonna load it up with 2 heaters, 200 watts apiece, PTC base, so they're gonna go up above their rating for a few seconds. It's kind of warm in here, so they probably won't go that far, but we'll see. Turning on the first one, turning on the second one, and it's outputting, and it's not shutting off. 246, 299. It might top out at 500 watts. 437, 484, and the display turned off. 518, now it's come back down again. 504, 486. Should settle it back to around 400 watts, give or take. And then I want this to soak for a while, and then we'll throw the thermal imaging camera on it and see if there's any hot spots, anything of concern with this. I don't want to run it for too long because it doesn't have the shroud on the top to keep the airflow running across it, because this is actually drawing more than what was on the PowerHouse II 400. Pretty sure this is a 1750 VA inverter that it probably can take quite a bit of an output. Although I'm pretty sure if I were to go beyond 500 watts, it would just shut off. So let's check real quick to see where we are as far as output. Hanging right around 400 watts, which is what you'd expect for each of these. And we'll come back and see where we're at with thermals. It's been about 15 minutes. We're now seeing the battery level drop pretty quickly here, which is what I expected, because it didn't get a chance to fully charge and balance, so the state of charge is not particularly accurate. I don't want to run it too much longer here, so I might start backing it off pretty quickly. But what I do want to show is that the fans have both kicked on. That's what I had a little clip of before. And the temperatures seem to be fine. Everything seems to be good. Nothing seems to be heating up too much. I do want to check the temps one more time, because as the voltage drops on the batteries, the current's going to keep going up. So now we're at about 18 amps coming off the batteries. So I'm going to do a quick check of temps and we'll come right back. All right, that was pretty awesome. So both fans are running. The hottest temps we saw were around 62 degrees Celsius. It's not really a fair test because this would have the cover over it and would have more directed airflow, which is why I didn't want to run it for too long. None of the MOSFETs here got any hotter than about 62 degrees Celsius. And these are 150 degrees Celsius rated parts. Obviously, the cooler they can run, the better. All the cabling looks good. Nothing looks like it's overheating. I did poke the camera carefully through here to see if anything on the back side of the PCB looks like it's overheating. It's not. What I want to do is invert this back, because I have to reassemble it. Put everything back together. Ensure that if you take this apart, you do put this cover on. Now, not only is it a protective cover, but it helps direct the airflow and to keep all of the converters and inverters cool. Just a quick check-in here of how this thing should look when you reassemble the fish paper and the whatever this is, this plastic sheet on top. This should go down from the top, and then all of this should be folded underneath. All the fish paper should be folded underneath. It has adhesive on it, so you can kind of push it against the printed circuit board and it'll kind of hold for a little while, but then it'll pop back off again. But then this goes on top of that, and then this plastic piece really needs to be in place to screw everything down and hold this sheet in place. And it has two little tabs on the front that this really can only be oriented in one way. Just a shot here to get the correct orientation of those aluminum rails. They'll only go in one way, but I'd show them here, reinserted, because they're free floating once the screws have been removed. So let's get the battery back in and connect everything back up. My initial complaining aside, I can see now what Anker was trying to do with this design, and that was put all the connectors on one side of the assembly. And they sure did. I mean, all the connectors are now on one side, so you're not trying to get something fished in there and connect it with your fingers in between the front side of this thing, like there was on the PowerHouse II 400. So yes, this is a better design, and this looks like it's designed to just slide into the rail system in here and then provide guides for the wiring. Battery is in, you got to rock it back and forth, make sure these aluminum frame rails stay aligned, and then you'll eventually feel the battery slot into place. And now I'm just going to put the 4 screws on the bottom back in so that the battery doesn't move around when I'm trying to make all the connections, and we'll give it a test. Here it is, reassembled. We've got all the connectors back in place. This one's a pain. I had to push on this to try to keep it away from these 2 features so that when the back panel comes back on, it won't press that connector back in. It's going to compress the wire a little bit, but as long as it's not moving around all the time, it should be just fine. This is all signaling wire, no high currents being passed through this. Here's everything all connected back together. The only thing is left is for that light bar in back, which has a 4-pin connection, which will be reassembled once I get the back panel on. Before I do that, I want to test this out. First thing I'm going to do is do a full charge on it as fast as I can get it to charge. So I'm going to connect everything up. The main 125 watt adapter, a 70 watt, and another 60 watt adapter, going to charge as quickly as it possibly can to see if we have any issues with heat. Okay, this has been charging for over an hour at 225 watts. Let's just show you that it's actually 228. Pretty close to the maximum charge we're going to get out of this. So the temperatures on it seem fine. Everything is reassembled. The last test I'll do will be loading this to basically its maximum output, which is 400 watts on the outlets and then 120 watts on the car socket. And then I'm going to load the output on the USB-C to 120 watts. So that'll be 640 watts, which I think the maximum output on this is about 750 with all the ports combined. Anyways, get it really close to that. Run it all the way down from 100% fully charged down to about 10 or 20% just to test to make sure nothing gets unhappy when it's close to maximum load. Clip in the connector for the rear light. This goes all the way back in, and then put all the 12 screws back in. And then it's just the 2 trim pieces that go back on. These 2 little trim pieces here. That snuck out there. Let's get you back inside. There you go. Get back in there. Well, that's it. It passed all the testing that I wanted to do. Nothing got exceedingly warm, and I just finished putting it all back together with the 12 screws on that back panel, and then put both the back panel LED diffuser and the back panel fascia plate. And then the whole thing was reassembled, and it's been some time since I originally recorded this, and it has been working great. For those that asked in the first video what happened, I'm not really sure. I really do feel like it was just something pertaining to the battery management system and it not particularly liking the way that I was using it the night before, where I was trying to pass through charge while using the AC inverter. I don't think it liked that, especially when the battery was at a low state of charge. So perhaps a bug in the firmware, not necessarily in the BMS, but in the operating control part of it. But I feel like that was more of the issue. Again, there was no indication of any water ingress or anything like that. So that's it. It's functioning great. So thanks for watching, and I will see you in the next one. Take care.